Thanks, Jim. I'll be playing the part of Brian Jeffrey this afternoon for a while, but I don't know anything about American alligators. Well, you don't want to know what I know about alligators. So instead, I'll try and keep us awake in the post-lunch period by talking about delayed Cypress mortality and smoldering soil combustion. These are two areas that I looked at when I was doing my dissertation research on fire ecology and landscape ecology here in New Cypress. Found it to be a great place to work. I've just finished and graduated in August with my PhD at the University of Florida. Had a lot of help, thanks. A lot of help from Jim, who's on my committee, and everyone from fire to resource management to the administrative staff here. So this has been an outstanding place full of wonderful hosts and lots of fascinating questions. So I'll just talk about a couple of these interesting things today. So one of the things that I've liked about studying fire and wetlands, other than the fact that you occasionally get to set the woods on fire, is that it seems like kind of an oxymoronic concept to a lot of the uninitiated. I always like to show this picture because it actually shows a wetland withstanding water with some nice tall flames. As just about everyone in this room who's been around here knows, however, these events happen quite often here in New Cypress. And one of the reasons that this happens is this frequent juxtaposition of wetlands, such as these Cyberzones here that you see, just butted right up next to fire-dependent or fire-prone upland communities, music communities, like these transitional pine rocklands or pine flatwoods that you see in this photo. The other reason, or one other reason why that occurs, is we have this very strong seasonal distribution of rainfall. Again, everyone here is familiar with the rain and the dry seasons. This is just exemplified and illustrated by this Eden graph from within the preserve, just showing seasonal oscillation of water levels above and below the red line, which is the soil surface at this particular sensor. And as everyone who's been around here for a few years knows as well, in 2009 we had one of these exceptionally dry periods. And of course, the end of the dry season coincides with the beginning of the rainy, wet thunderstorm season, which is what happened on April 22nd, 2009. There was an air that found its mark, and it ignited the fire that became known as the Deep Fire. Because of the long historic drought that we had during that period, virtually every community within the fire perimeter was affected, so it didn't skip over a moist place or a wet place. There was very little to no water, and all these communities got affected. This ended up being, I think it was actually a good bit over, maybe over 27,000 acres. I think it was closer to 30,000 acres in the final tally. This is one of the maps that Mindy Wright kind of provided. And so this was the northwestern corner of the preserve, extending over into the Panther Refuge as well. This is where the first study took place. You can also see, this is a little bit more central into the preserve, but you can see that the landscape is really characterized by this kind of mosaic distribution. The gray circles here are Cyberzones, and for reasons that are subject to a different talk, they're actually distributed rather evenly. It's a patterned distribution, so they're really scattered quite thoroughly across the landscape here. This is just another illustration of how, well, first of all, the best way to see the preserve is really aerially, either flying into Miami on the left side of the window, or in this instance, via helicopter. You can really get a sense of how these Cypress, these scattered patchy wetland communities, just extend, in this case, far as the eye can see. So we were interested in what the effects of this fire were on forest structure, on the cypress trees within these cypress domes. So this study had a couple of aspects to it. We identified all of the cypress domes within the burn perimeter, and we randomly selected 25 of them. We looked at fire severity in two different spots within each of the cypress domes. First, one spot out toward the edge of the dome, and one spot at the interior of the dome. And to measure severity, we used the ground-based method. That's the component of CBI, which is Composite Burn Index method. That's a way of just getting a handle on how severe the fire was. So within the same area, we also did the Cypress mortality census. So within just a few months, or actually within several weeks after the fire, we noticed that all but about 0.5% of the trees had leafed out again. So our initial thoughts were, well, maybe cypress trees don't actually die, or maybe they don't seem to be killed by fire. So we came back the following year, just over a year after the deep fire occurred, and we found that just under a quarter of the trees had died. So 24% delayed mortality by 1 year. Incidentally, as a follow-up, we came back a third year and found that only 2 or 3 more trees had died, only about 0.5%. So we have this initial flush out of leaves, followed by a significant mortality event, and then that's pretty much all we seem to get from this fire. In terms of the severity, you would predict from landscape ecology theory or from a walk in the woods where you go into a cypress dome and notice that the soil seems to get moister, it seems to get a little bit cooler, shadier, that we would get some lower fire severities in the center. And that's exactly what we saw. So these numbers here represent the values that we got from the severity measurement. 0 is unburned, 3 is sort of a thermonuclear char, and we saw a significant difference from the edge going to the center of these cypress domes, both overall, which is these numbers in the blue areas, but also when we decompose the composite measurements into understory and overstory. I almost said fuels like a good fire scientist, or vegetation, which is what you say if you're an ecologist. So we took these factors that we imagined might predict mortality. We said, well, what is it about this particular tree or its place that could determine whether or not it lives or dies after a wildfire such as we've seen in this deep fire? So we looked at a number of factors and we found 2 significant predictors of mortality. This seems at the same time kind of an elegant, also overly fancy way of illustrating this. But if you just look at these different colored lines, those represent one of these 2 factors. Those represent diameter, crest height, tree size. The other factor, hydro period down at the bottom, that's just the number of days that a particular location right next to the tree experiences inundation. That's another way of expressing the local soil elevation, which we determined from Eden measurements partly. But basically, the larger a tree is, the better it survives fire. And the lower the elevation, or the longer the hydro period following the fire, the more likely the tree is to die. So that's just probability of mortality over there on the y-axis of the graph. So these are just different models showing those different mortality probabilities for trees of different sizes that you might encounter in the preserve. Without a fancy graph, you can also intuitively see, the reason we call cypress domes domes is because of this characteristic profile. And we know from prior work, some of which has been done here, some of which has been done by some of you, some of the reasons for why we have that dome shape. There are adaptive factors. The soils are deeper in the centers of these domes. They tend to be a little bit lower elevation. The water pools there in the center, so you have less water stress. And we wondered, and we thought it may have something to do with fire as well, but this seems to be the first time we've been able to quantify that to some extent. Fur, E, seems to play a role. It should be fire. But we've identified a mechanism behind fire's role in maintaining or exaggerating the dome shape of these cypress domes. So out at the edges where you have small trees, top kill seems to be what's happening, where you have repeated or even occasional fires that will come through, kill these trees, or kill their tops. And then the smaller trees tend to resprout pretty well. So regular repeated fire tends to keep the tree heights relatively low. And if you look at pre-fire tree heights versus post-fire tree heights, you get a decrease. And something different seems to be happening in the interior. These smaller trees don't take fire as well, but they also don't resprout because they're a little bit too large to do that. So they get killed outright. So there, if you take the mean living tree heights pre-fire, compare it to the mean living trees that have survived the fire a couple years afterwards, you actually get an increase in the mean live tree height. So that's how you get taller trees in the centers of domes, shorter trees at the edges of domes as a result of fire. So cypress, both pond cypress and bald cypress, occur pretty widely throughout the southeast. And while fire does not occur in these ecosystems by any means in all of these ecosystems all the time, or even periodically, these findings could perhaps be applicable to other places where you do have occasional fire. That may even be once every century that occurs in some of these ecosystems in the southeast. So another topic that I was interested in for my dissertation was in smoldering combustion. I like to think of this as wildfire in slow motion, which is really great for those of us who don't like to get up very early and predict where it's going to be weeks later even. We know that flaming combustion gets a lot of press attention, especially when houses in Southern California and 747s dropping fire retardant seem to be involved. However, we also know that smoldering combustion, the ground fires, you'll also hear them called peat fires that occur, those are also significant events. They have serious impacts on air quality. They have serious impacts on motorist safety. As we know too well here in Florida, that can combine with fog to create super fog incidents. And globally, smoldering fires are the most ancient, the most long-lasting fires that occur, and they also, in many cases, will burn substantially greater amounts of fuel than flaming forest fires. But they do occasionally get media attention, such as we've seen with the Okefenokee fires. We saw Russian peat fires, and of course fires in Indonesia have gotten a lot of attention in the previous decade. We see these fires down here in Big Cypress pretty regularly for the reasons that I mentioned before. We'll go in the wet season from a nice flooded cypress dome or cypress strand or slough to, depending on the size and hydrology of the dome and the hydrology of the year, to a really nice, fairly thick bed of organic soils, fuels, duff, and these larger fuels which act as ignition vectors is the term fire scientists can use to refer to this, where you'll get one of these logs to begin smoldering, burning, and it will just act like a wick to transmit the flame into the duff there. And so if you think about the geomorphology, the architecture of a cypress zone, you've got this layer of sediment in the middle. What this graph doesn't show is the fairly thick, in some cases, layer of organic soil, duff, peat, take your pick of terms there, which accumulates toward the centers. And that can be, depending, again, on a number of factors, it can be a meter or more thick. So that can be fairly substantial in terms of the amount of time this material can take to burn, the emissions it can produce, the carbon it can release. Just here's an illustration of that process occurring during the Jarhead fire last year. So one of the things I was interested in was, so what are the controls on this? What are the influences that turns out of soil moisture, which is the main driver of this, on smoldering combustion? And second, what are some potential values for carbon release? So what are the kind of global scale implications from extensive smoldering fires in this area, our cypress peats here? My apologies, the only thing that I think is misrepresented here is my assistant Marissa would want you to know that she's not actually stretched to a 16:9 ratio there. This is otherwise a pretty good representation of the lab study that we were able to do. We were not able to do a field study last year, in part because of the Jarhead fire. We picked the one dome for instrument. But we did get some good measurements from cypress cores we collected and then processed and burned in the lab, wrapped up in insulation like giant pieces of sushi here. And we looked at different areas of the preserve that were kind of representative of the landscape configuration. So you have over here on the left, a section from the deep lake, from the middle here, from the southern part of Raccoon Point, and on the right hand here, this is kind of the area to the northwest of Raccoon Point, just representing 3 different configurations, representing the mosaics you find here in Big Cypress. And these are 1.5 by 1.5 kilometer landscape blocks for scale. Looking at the factors controlling smoldering combustion, it does look like the moisture content of the upper 10 centimeters of the soil seems to be the greatest predictor. So we partitioned these samples into 3 different layers for the purposes of this analysis. That's because the fine roots tends to occur in the upper 10 centimeters, so that really seems to drive the smoldering behavior. We added soil moisture in this second layer, and that seems to help out a little bit. We looked at other factors like, for you soil scientists out there, bulk density, particle density. We looked at mineral content and a couple of other factors as well. And so those really fell out of the analysis as not significant. So really, moisture seems to be, I mean, that's also pretty intuitive, right? Wet stuff can't burn. But we found out, and you can kind of see here, soil moisture is on the bottom here. There's some fairly wet samples that we got to burn. There are a couple that I think might be obscured by the legend there, where we actually got soil consumption when moisture contents were over 200%. So, in other words, if you take the soil and dry it out and it weighs a pound, you could actually have 2 pounds of water absorbed into that soil sample, and it will still smolder. So that actually feels pretty moist. We also looked at landscape factors. So we looked at the distance away from the edge toward the interior of the dome that you have these samples, and how the moisture content could vary. Because we thought, based on the last study, that there's probably an effect there. And it turns out there is an effect on moisture, which in turn is going to have some effect on your smoldering behavior. It's not a terribly significant or terribly great effect, but there are some implications for our management of natural resources here. So if you think about large domes versus small ones, your larger Cypress domes are going to have a greater propensity to have moist interiors and less of a tendency, less likelihood, given the same environmental conditions, of burning than you would for a smaller Cypress dome. However, the balance of that is that your larger Cypress domes are going to contain generally thicker organic soils. Once they start burning, they're probably going to be more persistent. So that's just one thing to kind of keep in mind there. Excuse me, I also had a Coke before. We also saw a pretty significant variation in the organic soil area among these landscape blocks. As you can kind of imagine from just the different numbers of these gray circles that you see on these blocks. So there's a great difference in the amount of organic soil in different regions of the preserve, of course. And those combined with these fairly conservative measurements that we took out of these domes sort of midway through the dry season, which were, of course, not even as dry as it got just before the Jarhead fire. Those indicated that if you were to have a widespread smoldering fire, one that's maybe hundreds of thousands of acres here, that you could have some fairly significant emissions from these fires. So the estimates that we got with this method were anywhere from about 2.8 to 5.6 kilograms per square meter. So for those of you who don't have calculators, that's anywhere from 100 to close to 300 tons of carbon per acre in a fire that could occur. So thinking about regional emissions or even global, if you're concerned about carbon emissions, that's really something to pay attention to. So to kind of sum up the findings from these 2 studies, going back to the first part, we seem to have made some of the first measurements of how fire really does contribute to the shape of Cypress domes and their structure. We found out that Cypress peat can burn while surprisingly wet. And another thing I didn't mention is the methods that we used to look at smoldering combustion. We looked at both organic carbon consumption, basically how much burned, so we just weighed before and after, and then calculated the amount of carbon that had been burned off. We also did a common measurement looking at the change in height from the soil profile before versus after it burned, and that's called depth of burn in fire studies. And rather surprisingly, it didn't really seem to hold up here very well. So here, it seems like this SOC method seems to be better than measuring the change in height. And finally, comparing this to other studies that have been done on smoldering combustion, these Kalimantan fires that happened in Indonesia, which I guess the 97 event has been the most studied, but these continue to occur in these really deep, thick tropical peat deposits. Those have been estimated as well to contribute a certain amount of carbon to the atmosphere. But rather surprisingly, the amount of soil organic carbon released to the atmosphere from Cypress peats that we measured here seems to be somewhat greater, up to I think about 20% greater than the estimates from Indonesia. So while we don't have nearly the number of cubic yards of peat or tons of peat here, on a kind of pound per pound basis, we really do have a lot of potential for either storing or, in the case of ground fires, emitting carbon to the atmosphere from these fires. This is something that the more I think about, the more interest I have in continuing to work with it. One of the things that you see once you start kind of paying attention to these smoldering fires is how it really seems to be patchy and really seems to scour out patches from peatlands and from the centers of Cypress domes. And we know, and a lot has been talked and written about the potential effects of this phenomenon when it occurs in the center of Cypress domes. If you think about these areas that are like stadium domes, or some people call them donut holes in the middle of these domes, that might be the reason why these things formed. And there may be a contribution here to habitat quality for wildlife. So although these events might occur only very rarely, maybe every century or two, they could leave these persistent areas that create pools, that concentrate prey, that provide watering holes late in the dry season. And from a fire management perspective, everybody knows that these smoldering fires are really bad. You want to hopefully prevent them from occurring. You want to attack them aggressively if you can, even though they're very tough to put out when they do occur. And one of the things that we don't know very much about is whether there could be some ecological benefit when these things occur. So that's one of the areas where I think it would be an excellent idea to focus next, is to just consider what we might be losing in terms of ecological value when we do these active suppression activities. Not to try and discourage that from happening, but just to know whether there may be some value that we try and recreate in some other way when these fires happen, or when they don't happen. I've received a lot of help and support. I won't mention all these folks, other than Jim, who seems to be mentioned at almost every talk, and he's been a great host here. I would like to mention the Southern Fire Exchange, which is a consortium of researchers and managers and landowners whose mission is to get information out to interested parties on fire research. So there are some information sheets up here on this work and some other work on smoke and smoldering research. So come up here and take a copy later if you'd like to. So I think I've run a bit over into my own time.